Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. This is lesson 11, volume with fractional edge lengths and unit cubes. Classwork opening exercise. Which prisms hold more 1 inch by 1 inch by 1 inch cubes? How many more cubes does the prism hold? Okay, so what that is asking is, what is the volume? If we take little teeny 1 inch by 1 inch cubes and we put them in here, picture the cube in here, there'd be a three-dimensional cube here, and they'd pile up and they'd go this way along the bottom and along the side here all the way over this way. Okay, not a very good picture of cubes, but that's the idea here, because this is going to go back here, and this is the floor, and this comes down like that. So if you can picture piling up a bunch of cubes that are 1 inch by 1 inch by 1 inch, how many of those cubes will fill this? Well, that is the actual volume of a prism, and volume equals base area times height. But before we find the volume, we need to know what base area is. And the base area in this situation is, let me erase that, it is this rectangle on the floor right here. That is the shape of a rectangle. That is my base, and the area, which this capital B means, it means the base area is base times height. And the capital B and the lowercase b are two different things. This is little b. This is h. Little b times h gives me the area, which is capital B. Okay? So the base area is what we need to find first, which is 10 by 4. So 10 inches times 4 inches. So the base area equals 40 inches squared. So the first thing you always focus on when doing a volume problem with a prism is the base area. So this is 40 inches squared, so now I can substitute in my givens. The volume equals the base area, which is 40 inches squared, times, now this is the height of the prism. So notice there's two h's. There's a base and a height of the bottom area, but then the height of the prism is a different h. So try not to confuse all this. Some could use length times width here, so it's L and W and then H. So let's do that. So let's change this B. I'm just trying to explain really carefully what these values mean. So let's call this length instead. Call this width. And therefore, this would be length times width. That's my capital B. And now there's only one H. Okay? Does that help? And then if I take the area of the bottom, 10 by 4 is 40 inches squared, and then multiply by the height, 6 inches, then I get my answer to be the volume equals 6 times 40 is 240. Inches squared times inches is inches cubed. Which means there would be 240 1 by 1 by 1 cubes that would fit in this prism. Now we're going to do the same over here. So let's call this L, let's call this W, and let's call this height, H. So if I come over here and over here, okay, that is my base, which is a rectangle. So my capital B is what I focus on first, and that is length times width. So my capital B equals 8 inches times 5 inches. So my base area is 40 inches squared. So I'm going to use this in my volume formula. And my volume formula is base area times height. So my volume is this base area of 40 inches squared. And I'm going to multiply it by the height, which is 12 inches. So the volume is, okay, if I multiply 12 times 40, 4 times 12 is 48, and then I just put that 0 after. It's 400 inches, and squared times 1 is cubed, because we add our powers. So the volume is 480 cubic inches. So this rectangular prism is larger than this rectangular prism. So it says, which prism holds more? Well, the answer is this one holds more. How many more cubes does the prism hold? So then I'd answer this by saying 480 inches cubed minus 240 inches cubed equals 480 minus 240 is 240 inches cubed. It holds 240 cubic inches more than this one. And you should write that, but I'm just going to move on from the video. And if you want to pause it and write that down, go ahead, but I'm moving on. Okay, so now example one. Move this out of the way. A box with the same dimensions as the prism in the opening exercise is used to ship miniature dice whose side lengths have been cut in half. The dice are 1/2 by 1/2 by 1/2. How many dice of this size can fit in the box? Okay, so how many dice of this size can fit in the box? We have to take a look at a cube that is 1 by 1 by 1. So let's look at an aerial view of this. So we're looking straight down on this. So this is 1 inch, and this is 1 inch. Okay, and if I have a cube that's half that size by half that size, that would be a line segment going across here, cutting it in half and cutting this in half. So this is 1/2 by 1/2. And this is 1/2 by 1/2. And this is 1/2. And this is 1/2. And this is 1/2. And this is 1/2. Okay. So I bet you thought that just because the dice are a 1/2 inch longer, then they would take 2 cubes if it was half the size. In this case, each dimension is a half. So look what's happening here. In order to, if we cut a cube in half, we actually need 4 of them to cover this base, because a 1/2 by a 1/2 is only covering a quarter of the bottom. Because 1/2 times 1/2 is 1/4. Think of it that way. And that is just our bottom level. So then when I 3D this thing, and this is 1, then I realize that I have to go halfway. So there's going to be 2 levels to get up to total 1 inch. So I have 4 cubes here. So if I made this 3-dimensional, this would be a little bit tough here. Okay, 3-dimensional cube sitting here. And another one here, and another one here, and another one here. It's half full if this went up to 1. So I would need another cube that is going to be 1/2 by 1/2 to pile up on top of this one. And that would be 2 cubes. Okay. So if I have 4 on the bottom, then it takes 4 on top. So it would actually take 8 times as many cubes, because it takes 8 cubes to fill in 1 cube that's 1 by 1, if they are a 1/2 inch by a 1/2 inch. So now, if I do the same area, I'm not going to regenerate all this information. It's still up here. It was the same, 10 by 4 by 6. And we got 240 cubic inches. So if the volume equals 240 inches cubed, and then we say how many cubes will it take to fill that, when each cube is 8 1/2 inch by 1/2 inch, it takes 8 cubes to fill 1 cubic inch. Then I need to multiply this by 8 to determine how many cubes would take to fill that. So if I do that, 8 times 4 is 32, 8 times 2 is 16, plus 3 is 19. It would take 1,920 1/2 inch cubes to fill it. Okay. So it is 8 times as many cubes, even though we only cut a cube in half. Pretty crazy stuff. Okay, example 2. A 1/4 inch cube was used to fill the prism. How many 1/4 inch cubes does it take to fill the prism? Now, if we think about that, If this is 1 by 1, and I only go over a quarter, a quarter, a quarter, a quarter, half, quarter. So we are going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 cubes. Okay. So a quarter-inch cube was used to fill the prism. How many quarter-inch cubes does it take to fill the prism? Focus on a 1-inch cube first, and that is just one layer of 16. And then now there will be 4 layers. So 16 times 4 is 72. Okay. I'm sorry, it is 64. I thought that sounded weird. That's why I paused it. It is 64. So, how are we coming up with this value? There is going to be a pattern, I bet. So, we are going to have 64 cubes per square inch. So, how many quarter-inch cubes does it take to fill this prism? Well, we have to find the volume first. So, what is the volume of the prism? How is the number of cubes related to the volume? All right, so how many quarter-inch cubes does it take to fill the prism? Well, it takes 64 cubes to fill 1 by 1. Now we have to find the volume. So the base area equals length times width. The base area equals 1 1/2. I'm going to convert that into an improper. Inches squared times 1 inch squared. So the base area equals 3/2 times 1 is 3/2 inches cubed. So, squared, I'm sorry, inches squared. So the area of the base, which would be here, is 3/2 inches squared. The volume equals the base area times the height. The volume equals 3/2 inches squared times the height, which is here. 4 times 3 is 12, plus 3 is 15/4 inches squared. Now multiplied, 3 times 15 is 45, 2 times 4 is 8 inches cubed. 8 goes into 45, 5 times 8 is 40 with a remainder of 5, so it's 5 5/8 inches cubed is my volume. So there are 5 5/8 cubes that are 1 inch by 1 inch. So now if I want to know, so that is the volume of the prism. So the volume is right here. Now it says how many quarter-inch cubes does it take to fill the prism? Well, there are 64 cubes per cubic inch, and there are 5 5/8 cubic inches. So I take 5 5/8, and I'm going to go back to this format, which is improper. And I'm going to say 45/8, which is the area of this, or the volume of this, I'm sorry, the volume of this. And then how many 1 inch squares is in there is 45/8, and each 1 inch cube has 64 cubes in it that are a quarter inch by a quarter inch by a quarter inch. So I'm going to multiply this by 64 over 1. Now, a lot of students don't like working with fractions, but I love fractions. This 8 and this 64 will reduce. 64, 8 will go into 64 8 times. Make that a 1, so I get a 1 in my denominator. 8 times 5 is 40. 8 times 4 is 32, plus 4 is 36, so it's 360 cubes to fill this 5 5/8 inch cubic inch rectangular prism with quarter-inch cubes. 360 quarter by quarter by quarter cubes. Exercise 1. Use the prism to answer the following questions. Calculate the volume. So the first calculation with volume is the base area. The base is a rectangle. The base area is length times width. Substitute in the givens. The length is 5 1/3. I'm going to convert this to improper 16 over 3 centimeters times the width, which is 2/3 centimeters. So the base area equals 16 times 2, which is 32. 3 times 3, which is 9. So 32 over 9 centimeters squared is my base area. Step 1 done. Step 2, volume equals base area times the height. So the volume is my 32/9 centimeters squared times the height, which is here. 3 times 1 is 3, plus 1 is 4. That is 4/3 centimeters squared. I am going to multiply these, so I do not have to have common denominators. We're not adding or subtracting. 4 times 2 is 8. 4 times 3 is 12. 128 in the numerator. 9 times 3 is 27 centimeters squared. So if I want to make this mixed, then I go to my calculator. And there we have it. 128 divided by 27 is 4.74. So I know that that volume is 4. So 27 times 4, I need my remainder. 27 times 4 is 108. So that's 20 remainder. Okay, so 4 and 20 27s. If you have to fill the prism with cubes whose side lengths, centimeters cubed. Okay, so this is not a squared, and this is a cube. Centimeters squared times centimeters is centimeters cubed. So there is my volume. I got lazy with my calculation. B, if you have to fill the prism with cubes whose side lengths are less than 1 centimeter, what size would be best? Okay, so now if we look at our dimensions of this thing, 5 1/3, 2/3, 1 1/3. I would bet that the 1/3 by 1/3 by 1/3 centimeter cube would be the best fit. Okay. So we can take up those areas and not have any spaces. So how many cubes would fit into the prism if they're 1/3 by 1/3 by 1/3? Well, if I take a square that is 1 by 1 and I break it into thirds, 1 2 3 1 2 3 1 2 3, there would be 9 times 3, which is 1/3 times 1/3 times 1/3, which equals 1/27th. Each cube would be 1/27th of the area of 1 cube. So I take 27 cubes to fill up this area. So if I take my volume, which is 128 over 27, and I multiply that by 27 per cubic inch, then the 27s cancel and I get 128 cubes will fit if they're 1/3 inch cubes. Use the relationship between the number of cubes and the volume to prove that your volume calculation is correct. So what I could do there to figure this out is take the 128 cubes, and multiply that by 1/27th, one tiny little cube within those 27 cubes in the 1 inch. Centimeters cubed, and I get 128 over 27 centimeters cubed, which equals 4 and 27 centimeters cubed, which is what I got for my volume here. Okay, number 2, calculate the volume of the following rectangular prism. B equals, it is a rectangular prism, length times width. Substitute in the givens. Length is 8, 9, 10, 11 fourths times, actually put cm, times 1/2 centimeters. So the base area is 11 times 1 over 4 times 2 centimeters squared. Volume equals the base area times the height. So the volume is 11/8 centimeters squared times the height, which is 4 plus 1, 5/4 centimeters. So the volume is 55 over 32 centimeters cubed. Okay. B, capital B, my base area is length times width. My length is 10/3 inches times my length. 3 times 3 is 9 times, plus 1 is 10/3 inches. So B equals 10 times 10 over 3 times 3 inches squared. So my volume equals base area times the height. My base area is 109 inches squared times my height, which is 5 times 3 plus 2, 17/3 inches. So the volume is 17 times 100 is 1,700 over 9 times 3, which is 27 inches cubed. Okay, which that is going to come out to be 62 with the remainder of 26 inches cubed. Okay. All right, I am nearing class time, so I am going to pause this video, and we'll see you in a bit. Okay, a toy company is packaging its toys to be shipped. Each small toy is placed inside a cube-shaped box with side lengths of 1/2 inch. These small boxes are then placed into a larger box with dimensions of 12 inches by 4.5 inches by 3.5 inches. What is the greatest number of small toy boxes that can be packed into a large box for shipping? Okay, so the easiest way to do this is to make a fraction represent everything in terms of this fraction right here, the box that's going into the bigger box. So 12 inches is the same as 24.5 inches, because 24 divided by 2 is 12. So 24.5 inches, let's not put the inches in right now. So that is the length of the box. The width is 4.5 inches, so then I'm going to multiply by, I'm going to make this an improper fraction. 4 times 2 is 8, plus 1 is 9/2. And then 3 times 2 is 6, plus 1 is 7/2. So when I do this, 24 times 9 times 7, or 9 times 7 is 63. So if I do 24 times 63, it is 1,512. Have boxes, okay? So really I don't need these, I was just using that to explain where all these halves come from. How many halves are in 24, there, or 12? There are 24. How many halves are in 9 halves? 9. How many halves are in 7 halves? There are 7. So when I multiply all those, I get 1,512 boxes. Toys, the small toys will fit in the big box. Part B says use the number of small toy boxes that can be shipped in the large box to help determine the volume of the shipping box. Okay. So I take my number of boxes, which is 1,512, and I multiply that by 1/8. Okay, so right now you might be wondering, well, where in the world did this 1/8 come from? Well, if we have a volume is length times width times height, and we have a box that has a side length of 1/2, length times its width times its height equals 1/8, and that's where this comes from. Okay? And that is inches squared. So 1,512 times 1/8 is the same as 1,512 divided by 8. 8 goes into 15 once with a remainder of 7. 8 goes into 71 8 times, which is 64, with a remainder of 7. And 8 goes into 72 9 times. So 189 square inches is the dimension of that box. Okay. Number 4. A rectangular prism with a volume of 8 cubic units is filled with cubes twice. Once with cubes with the side lengths of 1/2, once with the cubes with the side lengths of 1/3. how many more cubes with 1/3 unit side lengths than cubes with 1/2 unit side lengths are needed to fill the prism? So again, the way I explained this was, if we have a square that's 1 by 1, and we cut it into halves, then this will be half the distance this way, half the distance this way, and it actually turns it into fourths. Okay, so this is a distance of a half, this is a distance of a half. 1/2 times 1/2 is 1/4. And we also we'd have 2 layers going up. So in other words, it's 1/2 by 1/2 by 1/2, which is 1/8. So that 1 square is 1/8 of the total area, or 8. There will be 8 cubes in a 1 by 1 area. And if I do it by 1/3, then if I take a 1 by 1 cube and divide it into 3/3 both ways, that's 1/3 times 1/3, which is 1/9. And then if I multiply by another third, because there's going to be 3 layers of these, if we're looking at it 3-dimensionally, then it's going to be 1/9. So each one of these is a 1/9. Actually, yes, 1/3 by 1/3 is 1/9. Multiply that by the height, and there's going to be 9 squares per level, 3 levels. That's going to be 27 squares per square inch here. And this is going to be 1/4, which is 4 times 2, which is 8 squares, which is 1/2 cubed. So that's really what we are doing. We're taking the dimension and cubing it, and that is 1/2 times 1/2 times 1/2, which is 1/8. And then down below here, I would say 1/3 cubed is 1/3 times 1/3 times 1/3, which is 1/27. So every square is 1/27th of the area, or volume, I mean. Okay. So it says, how many more cubes with 1/3 unit side lengths than cubes with 1/2 unit side lengths are needed to fill the prism? So the first thing I need to do is find the volume of the prism, and it is 8 cubic inches, or units. So what I'm trying to explain here is, when I take a 1/2 by a 1/2 by a 1/2, there will be 8 cubes in a 1 by 1 area. So if it is 8 cubic units, 8 units cubed, and I can put 8 cubes in each square unit, then I multiply it by 8, then that would equal 64 cubes. If I do the same with the 1/3, length of 1/3, then we're going to get 27 cubes per square inch. And if it is 8 units cubed, that means there are 8 cubes that are 1 unit by 1 unit by 1 unit. And I multiply that by 27. 7 times 8 is 56, carry the 5. 8 times 2 is 16, plus 5 is 21. There will be 216 cubes in the one that's 1/3. So the answer is, how many more of the cubes with 1/3 length than 1/2? Well, it's the difference. It's the cubes of 1/3 minus the cubes with 1/2. So it'll be 216 minus 64. And that's 2 and 21 minus 6 is 15. There will be 152 more cubes with 1/3 by 1/3 by 1/3. Okay. Okay, B says, why does it take more cubes with 1/3 unit side lengths to fill the prism than it does with cubes with 1/2 unit side lengths? Well, the cubes are smaller, so the smaller the cube, the more will fit. And I'm not going to write that. Let's move on to 5. Calculate the volume of the rectangular prism. Show 2 different methods for determining the volume. Okay, so I'm just going to do the one method that I've been doing. There's my base. It is a rectangle. The area of the base is capital B, base area equals length times width. The base equals the length, 1 1/2 meters. I'm going to convert that to mixed, or improper. 2 times 1 is 2, plus 1 is 3. Length of 3/2 meters times the width of 3/4 meters. So my base area is 9/8 meters squared. Okay, so I found the area of the base. Then I take and I want to find the volume. Volume equals the base area times the height of the prism. We already found the base area, which is 9/8 meters squared. And then we look at the height of the prism, and it's 4½ meters, which is 9/2. So I change that to 9/2 meters, and I find my volume. 9 times 9 is 81. 8 times 2 is 16. Meters squared times meters is meters cubed. Okay, so the volume is 16 and 16 is 32. Plus 16 is 48. Plus 16 is 64. Plus 16 is 80. So that's 5. 5 times 16 is 80. And there's a remainder of 1/16 meters cubed. So the volume is 5 and 1/16 meters cubed. That is the only way I'm going to show that in the video. That is the end of lesson 11. Go do your problem set. And oh, by the way, smash the like.